This is Juan Burciaga doing a standard on standing wave string standing waves. Here we have a CDF file that shows two wavelengths, and then we have the sum of those both wavelengths here at the bottom. Um, for starters, we know that on a string we have nodes on both ends, and all nodes and antinodes alternate. Here, for instance, we have both nodes at the end, so node here. Let me fix that. Let's get a better view. Close enough. So it would be node, antinode, node, antinode, node. If we draw an imaginary line here where the line equals 0, just pretend that here, this circle here, the blue one, is below the line, which equals 0, and this red one's above. So here, if you add them both together, the both differences would be here at the top above 0, because the red one outweighs the blue one. Here, for instance, at this peak, at this cross section here, we would have the peak because of the sums. They're above the line. Here at the bottom, in this intersection here, they're below the line, so the peak would be below 0. And then that's it for that. For our calculations, trying to figure that for every node, for node and antinode, we know that it is a fourth of a wavelength. A node, antinode, node, we calculate that it's, from node to antinode is a fourth, so 1/4 plus another fourth is half, so we call it length is half of wavelength. And then, 1, 2, 3, 4, 4/4 with 2 halves, 2 over 2, sorry, so equals 1 wavelength. And we have node, antinode, node, antinode, node, antinode, node, which equals 3 over 2 wavelengths. So by doing our calculation, we know that the length is some integer times lambda divided by 2. The integer could be anything, any integer like 1, 2, 3, 4, etc., etc. And we also know that frequency equals speed divided by lambda. And out of that, out of the first equation, we can calculate lambda by doing our orders of operation. So lambda equals 2L over n. And with our frequency equation, we can plug that in. So speed divided by where lambda used to be, we got the new equation for lambda, 2L over n. So frequency equals speed divided by 2L over lambda. And then we arrange all that, so we'll find frequency equals speed times the integer divided by 2 lambda. Here on this side, we have our first, second, third frequencies, so we would plug the integers of 1, 2, and 3. So speed times 1 divided by 2L. Yeah, that's correct. And then the second frequency is speed times 2 divided by 2L, which we know that it's basically the second frequency 2 times the first frequency. Here we have F3, speed times 3 divided by 2L is the same way as saying 3 times the first frequency. Here we have a drawn plot spectrum from Audacity. So we know that it's basically the outcome of the first equation is 1, and then we know that it's 2 times the first frequency, 2, 3, 4, etc., etc. We have this beautiful even out space here, peaks, and then that should be it. Thank you for your time.